Alright, so let's quickly go through what frequency polygon is. So a frequency polygon is a statistical diagram that indicates the spread of a distribution. So frequency polygon in essence is just a line graph joining consecutive points. And a frequency polygon for ungrouped data is obtained by plotting the observations against the corresponding frequencies and drawing straight lines to connect the points. Now, something special about frequency polygon, seeing that it's a polygon, it must be a closed figure. So the two ends of the frequency polygon must always lie on the horizontal x-axis. So even though the points that we're going to be plotting won't end up on the x-axis, we must connect 2 points at the start and at the end of the frequency polygon so we can actually call it a polygon. So now the area enclosed by the frequency polygon and the horizontal axis is proportional to the total frequency of the distribution. What this is saying to us is that whatever area we get under the frequency polygon, that is basically the frequency. And that's for ungrouped data. So now let's look at an example. So a class recorded the distance traveled to school. The distance in kilometers is given in the table below. So the first row here represents the different distances, and the row here represents the frequencies. Now, using a scale of 2 centimeters to represent 1 unit on both axes, we're required to draw a frequency polygon to represent the data. Additionally, we're required to calculate the area enclosed by the frequency polygon on the horizontal axis. So let me zoom this in. Alright, so as we know, for these statistical diagrams, the frequencies would be on the y-axis and whatever else we're representing goes on the x-axis. Now they asked us to use a scale of 1 centimeter, 2 centimeters to represent 1 unit. So for each 2 centimeters, we simply put 1 unit. So going up by 2 centimeters, we'll put 1, 2, 3, 4, 5, 6, 7 until we have enough to cover all of the different frequencies. We have 6 as the highest and 7 as the highest distance. So over on the x-axis, we went up to 8. Alright, so now for ungrouped data, what we're doing is simply plotting the points as given in the table. So the first point is 1, 1, then 2, 2, 3, 4, and so on. So you see here we have 1, 1, 2, 2, 3, 4, 4, 6, 5, 5, 6, 3, 7, 5, and those would, here where you see the points highlighted, those are the points from the table. But based on what the instructions were for frequency polygon, we have to connect it to our x-axis to enclose the figure with the x-axis. So how we enclose the polygon is that we look at the distance between each point. So we realize that there's a 2 centimeter gap here. So that means if we were supposed to enclose this polygon, this would have been the starting point, and we would need to move 2 centimeters and bring it down to the x-axis. Similarly over here, we move 2 centimeters and bring it down to the x-axis. So now we have an enclosed polygon. So let me just copy this. Alright, so now that we have the polygon constructed, the next step is to find the area enclosed by this polygon. So what we'll have to do is divide this polygon into various shapes. And the shapes that we usually get are triangles and trapezium. So the first shape and the last shape will be a triangle. Now we can pinpoint this by breaking the shape. So at each point, we're simply bringing down some broken lines. So we're bringing down broken lines from each point. And when I'm finished, I want you to tell me how many different shapes you're seeing here. Alright, so how many different shapes do we have?
Sir, 8.
8. 1, 2, 3, 4, 5, 6, 7, 8. So what you're required to do is label these shapes. So this would be A1, A2, A3, A4, A5, A6, A7, and A8. So now, as I've mentioned, the first shape is a triangle, the last shape is also a triangle, and all the shapes in between are trapeziums. So we'll need to recall the formula for area of a triangle and formula for area of a trapezium. So the formula for area of a triangle is what?
Half base times height.
Half base times height. And area for a trapezium? Area for trapezium?
Sir, half the parallel sides and multiply that by the distance between them.
That's the height. So it's half A plus B.
A plus BH.
So these are the two formulas that you'll be using when working with frequency polygons. So now we've established that we're working with a triangle here, and all trapeziums in between. So now the total area under this frequency polygon is going to be A1 plus A2 A8. So A1, so we don't need to write the formula for each of these because we know what we're working with. So for A1, we're dealing with a triangle. And what are the distances, the different lengths? From here to here is 1. What's from here to here?
1.
So even though we are dealing with 2 centimeters, we're working with the units that have been represented on the x-axis. So this is from 0 to 1. So even though this is 2 centimeters, we still have to call it 1 because that represents the actual distance from the table. So the spacing doesn't matter. All we're looking at is the numbers that are represented. So this would be from 1 to 2. So this has a distance of 1. 2 to 3, distance of 1, and so on. So for the area of this first triangle, the base is 1, height is 1. So we can say this is half base times height. That's area 1. Now area 2, now this is where sometimes it gets a little bit tricky because this trapezium isn't drawn as how you would usually see trapeziums being drawn like this. This one is in an upright manner. So you see that it's in an upright manner. So what we'll have to do is look at the sides that are parallel still. So this is parallel to this one. So these would be the parallel sides. And this, the one down here, would be the height. Even though it's on the base, it would still be classified as the height if we were to rotate this trapezium. So now, the area for this would be half the sum of the parallel sides. So this is 1 and this is 2. So it's 1 plus 2 times the height, which is 1, plus area 3. Now we look at it the same way. We said, alright, this would be one side of our trapezium, and this would now be the height. So the parallel sides would be 2 and 4. So we say half 2 plus 4 times 1. And then we just repeat this until we factor in all the different areas. So the next one, and then now we're at the last shape, which is another triangle. So it's half base times height. The base is 1 and the height is 5. So that's just half base times height. Now when we simplify all of this, we get a half plus 3 over 2 and we get 52, which is equal to 26. And what did we say the area is proportional to? What is the area proportional to? So the area directly links to the frequency for a frequency polygon. And let's jump back to the question real quick. So we got 26 as the area. So let's count up the frequency. That's 3, 7, 13, 18, 21, 26. So whatever area you get under the curve for ungrouped data of a frequency polygon is going to be the same as the total frequency. So that's one way to know that you're correct. Clear?
Yes, sir.
So that's for frequency polygon of ungrouped data. And I've also attached a video. This is one of my videos that I've done on a question. So you can go ahead and watch that as well in your free time. So now, as you know, for these statistical diagrams, we do them both for group data and ungrouped data. Now this one is similar to the ungrouped data. The only difference is that we'll be focusing on the midpoints. So the frequency polygon for group data is obtained by plotting the midpoints of the class intervals against the corresponding frequencies. So that's the only difference. For group data, we're focusing on the midpoints. However, for ungrouped data, we're simply focusing on whatever frequency was given with whatever values. So that's the only difference for group data and ungrouped data. So now let's look at this one. So seeing that we're dealing with group data, we can't just say the area under the frequency polygon is going to amount to the frequency. We have to look at it in the sense that, seeing that it's grouped, each group would represent a set of numbers. So in order for us to find the total frequency from the area under the group data, we have to divide by the class width. So when we get the area, we're going to divide by the class width, and then that's going to give us our actual total frequency. So now let's look at an example, and then we'll do a question from the past paper, and that's where we'll wrap up today's session. I told you it wasn't going to be a long session, just that we needed to cover this, and then the recording will be sent to the classroom. So let's look at this one. So the table below shows the weights of the girls in a class. The weight given in kilograms. So 31 to 35, 36 to 40, 41 to 45, 46 to 50, 51 to 55, 56 to 60. And these are the frequencies. So before we move on, what's the class width for each of these classes?
Sure, 5.
How did you get 5?
Because each of the groups have 5.
Yeah, but how did you get it?
Because it doesn't.
So now, remember, if the examiner asks you to show the class width, you'll have to actually calculate it. So in order for you to calculate the class width, you need the upper class boundary and the lower class boundary. So this is 31, 35. Let's go over here. So if we have 31 to 35, and we want the class width from this, what we need to find is the upper class boundary and the lower class boundary. What is the lower class boundary for this?
30.5.
30.5. And the upper class boundary?
35.5.
And when we subtract, we're going to get the class width. So class width is equal to upper class boundary subtract lower class boundary. So 35.5 subtract 30.5, and that's 5. So this would be the class width, because they could ask you to calculate the class width, that's a total possibility. So you just know that you subtract the lower class boundary from the upper class boundary to get your class width. So now they ask us to draw a frequency polygon to represent the information, and then calculate the area enclosed by the frequency polygon and the horizontal x-axis, and hence determine the number of students in the class. So even though we could have counted the frequency to say that there are 15, 28, 30, 15, 28, 31, 32, 34 students. So even though we could have counted it, they still want us to find it from the frequency polygon. And in that regard, we'll have to navigate to finding the area under the frequency polygon. So what they did was that they constructed a histogram in the background, but we won't be doing that. A histogram is directly linked to a frequency polygon, because the histogram shows the continuity of the data, and the frequency polygon is simply the midpoints of those bars. If we were to construct a histogram and selected the midpoints of the bars, that in return would give us a frequency polygon for the group data. So that's one way. If you don't remember how to do the frequency polygon, just do the histogram, find the midpoints, and then you can just erase the histogram after. But it's just the midpoints we're plotting against the frequencies. So now at the ends, we can see where they connected to the x-axis. And for group data, it's very much similar to ungrouped data. So we look at the distance between each point. So between B and C, we would be at, what's this, 33 and 38. So that would be 5. So the spacing between B and C would be 5. So that means the opening point would be 5 away from B. So if this is 33, this would be at 28. And if this is at what's that, 58, this would be at 63. So that's how we'd have to look at it. And then the process is very much similar. Area of triangle, because we'd get two triangles, one to start and one to end, and then trapeziums in between. So the height in the equation is the perpendicular height, which is just the which is just on the x-axis, and the difference between the midpoints is used as the perpendicular height, which is what I said a while ago, on the x-axis. So here we can see where they calculated the area. So the area of the triangle here is 9 times 5, because 5 is the distance between. So 5. So what you notice is that the height, it doesn't change. So you notice that the height, so this is half base times height. The height doesn't change. So it's 5, 5, 5, 5. So once you've established the height for this particular question, it's going to be the height throughout the entire question. And if you were paying close attention around here, you can see that the height for this one was 1. And we had 1 all the way throughout the question. You notice that?
Yes, sir.
So once you identify the height, it's going to be the same height for all of the different areas. Now, they calculated this to get 170. And remember, for group data, we have to divide by the class width to get the frequency. So they divided by 5 and they got 34. This is just, well, let's see this activity. So the following frequency polygon shows the waiting time of a group of passengers as at a bus stop. So the waiting time of passengers is given here. What is the class width or size? Based on the frequency polygon, complete the table. All right. What are the values on the x-axis to construct the frequency polygon? How many passengers were in the group? All right, let's tackle this activity. All right, let's see. Can everyone see this clearly?
Yes, sir.
All right, so this one says, what is the class size or class width? and we just established the calculation for class width, upper class boundary minus lower class boundary. So remember that these are representing the midpoints. So if 6 is the midpoint, so 3, 4, so 5 would be somewhere in this region. Alright, this scale isn't the best. However, based on what we're seeing down here in the table, we can find our class width. So that's going to be equal to 7.5 subtract 4.5, which is 3. So the class width is 3. So that's why the distance between each of these points is 3. So from 6 to 9, 9 to 12, 12 to 15, and so on, because the class width is 3. So now, based on the frequency polygon, complete the table. Alright, so we have 8 to 10. And the midpoints. No, we were just adding the, because we know the class width. Yeah, so we're just adding the 3 going down, 3 going down. Wait, this is 19. What am I doing here? Alright, so we have our midpoint. So let's read the frequencies from the graph. So this is 5, 6, 13, 11, 4, and 1. So we have all our frequencies represented. We have the midpoints, we have the different class intervals. So what are the values used on the x-axis to construct the frequency polygon? What are the values used on the x-axis? I'm assuming this is asking us what the x-axis represents. So it would be the waiting time. Well, this is an ambiguous question because this could mean midpoints. We could answer this and say the midpoints are used on the x-axis.
Yeah, I think midpoint make more sense because you say the values that are used to construct the frequency polygon, and you can use the midpoint to construct it.
Yeah, the midpoints. How many passengers? Yes.
Why is the last waiting time 21 to 22?
Oh, it should be 20. Sorry. Someone is observant. Yeah, it should be 20 to 22. Because we're adding 3 going down. So 11, 14, 17, 20. Okay, good. So now, which class interval do most passengers belong to? How many passengers are there? So that's just looking at the frequency. So the one with the highest frequency would be that. So it's 11 to 13. So 11 to 13, and there are 13 passengers. How many passengers are there in the group? We can simply add up all the frequencies. So 5, 10, 21, 27, 30, 40. So there are 40 passengers in the group. What percentage of passengers waited for less than 13.5 minutes? What percentage of passengers waited for less than 13.5 minutes? So let's see. So 13.5. So 13.5 would be one of the boundaries. So it would be the upper class boundary for this class interval. So we need to count. So we're stopping at this because it says less than 13.5 minutes. So is everyone following? We have to look at where 13.5 could possibly be. And seeing that the boundary, the upper class boundary for this class interval would be at 13.5, then we can look at the frequencies for these class intervals.
Sure, but wouldn't it also be the lower class boundary for the next one?
But it says less than. So even if 13.5 would start here, we're looking at where it's less than 13.5.
Oh, I hear you.
So now we look at the total frequency for these classes. 11, so that's 24. And that's out of 40. So that's
60%.
60%. Alright, so they want us to find the average. So do you recall how to find the average for group data? Or do we find the average for group data?
So I think it's the highest plus the lowest divided by 2.
No, for group data.
Would it be like when you find the mean?
Yeah, that's the mean, the average. So it's saying find the average. So this is the same thing as mean. So mean of grouped data. So that's represented as x bar, and we find this by saying the sum of fx divided by the sum of f. Now x in this case, see that it's group data, the x in this case is going to be the midpoint. So we've already established the midpoints, we know the frequencies, so we can go ahead and find our mean. So this is going to be, so what we could have done is construct another column to represent fx, but we can just write that to the side. Let's just write it here, fx. That means f times the midpoint here is classified as x, and this is your f. So 5 times 6, that's 30. 6 times 9, that's 54. 156. 165. 72 and 21. So these are all your fx values, so we need to add them up. So that's 84, 184, 190, 240, 340, 405, 475, 477, 78, 98. So that's 498 is equal to 498 divided by the total frequency, which we established to be 40. So 498 divided by 40. Let me pull up my calculator. So this is 12.45. And what does this average represent?
The average frequency.
What is this question focusing on?
The waiting time.
Exactly. So x bar here represents the average waiting time, and the average waiting time is 12.45 minutes. And that would be it for this question. So we actually want to attempt a past paper question before we end. Even though this is quite comprehensive, this is a good question. In fact, the only thing is that we didn't calculate the area under this frequency polygon, but besides that, these are some good things that they could ask you from the question. Alright, so let's get the past paper question. Alright, so this is 2007 May-June paper 2. So this question says, a class of 32 students participated in running a 400-meter race in preparation for their sports day. The time in seconds taken by each student is recorded below. Copy and complete the frequency table to represent this data. Alright, so let's see what we can make of this. Alright, so what we're doing is basically counting the from this data set the numbers that falls between each of these intervals or limits. So 65 to 69, we look at what falls between that. So between 65 and 69, we have 1, 2, 3. So we have a frequency of 3. Between 70 and 74, 1, 2, 3, 4, 5, 6, 7. So that's 7. Between 75 and 79. 1, 2, 3, 4. So that's 4. And lastly, between 80 and 84. 1, 2, 3, 4, 5. So that's 5. So we've completed the frequency table and we got our 2 marks. See how easy it is to get 2 marks? Now let's see what else is required of us. So using the raw scores, determine the range for the data. Alright, so this is another free 2 marks. So how do we find the range? How do we find the range of a data set? Yes, so we need to look at the highest observation and then we subtract the lowest observation from it. Because look at what they said. They said use the raw scores. That means we're referring to these values, not the ones in, not the table. So we look at these values, identify the highest observation, which would be 83, and the lowest observation would be 51. So range is equal to highest observation minus so this is going to be 83 minus 51 and that's 32. So the range for this data is 32. That's another free 2 marks. So now it says using a scale of 2 centimeters to represent 5 seconds on the horizontal axis and a scale of 1 centimeter to represent 1 student on the vertical axis. So this is just the y-axis and this is the x-axis. Draw a frequency polygon to represent the data. And here they left they were so kind enough to leave us a note. An empty interval must be shown at each end of the distribution and the frequency polygon closed. So they're basically telling us that we must connect it to the x-axis at the start and at the end. So they were generous enough to remind us of that. Alright, so let me get a graph paper. Alright, so they said 2 centimeter, 5 seconds on the x-axis, 1 centimeter, 1 student on the y-axis. That's our x-axis. That's where 0 is at. So if we break the graph here, we can start at, let's start here. And let's call this one So if this is 50, this would be 45. Okay, you can hold. So this would be 50. $60. And then we go up to 90. Alright, so we have our graph constructed. Well, the axis labeled, and we have our points on the axis. So down here would represent time in seconds, and over here is just number of students. We're trying to get this as accurate as possible. So now remember, in order for us to calculate or to construct the frequency polygon, what do we need?
Upward and midpoint. Oh wait, no, yeah, Polygon, midpoint.
Yeah, we need the midpoints. So what's the first midpoint here?
Sorry, would it be 49.5 and 54.5?
Yes, so that's one way to find the midpoint, but well, we actually have an easier way by just adding the upper and lower limit and dividing by 2. That's one way to find the midpoint as well. So instead of finding the boundaries and then dividing by 2, we can simply add the limits, divide by 2.
Say 52.
52. What's the next one? So once you find the first midpoint, you know, the only thing we're doing next is just adding the class width to each of these midpoints. So the class width is what? 5. So we're just adding 5. So this is 62, 67, 72, and 82. And those would be the midpoints. So we're plotting all of these midpoints as in relation to their frequencies. So 52 will be plotted with 3. So for this one, each 2 of these small spaces would represent 1. So this is 50, 51, 52, 53, 54. So each 2 of these small spaces is going to represent 1. So 53 is going to be here. Well, 52. 52 is going to be here, and we're going to plot this with 3. So right here. So that's the first point. The next point is at 57 and 4. Here. Then we're at 62 and 6. 67 and 3. 72 and 7. Then 77 and 4. 82, and 5. So now my question to you is, what are the points that we're going to use to enclose this frequency polygon? So I'm going to be connecting these points first. So I want you to think about where this frequency polygon will be enclosed. What will be the first point of enclosure, and what will be the second one?
The class before the one that's there, and then for the closure, the class that comes after.
So give me the exact value. What are the values that I'm plotting on the X and Y? So remember, we need to have the same distance between each point. So if this point is at 47, well, not 47, 52, what would the point over here be? And we know that the distance between each of them is 5.
47.
So it would be at 47, 47, 0.
47, 0.
And over on this side, what would it be?
How much is that, sir?
This is 82.
87, 0.
So 87, 0 right here. And that's your frequency polygon. So now, wait, they didn't ask us for the area of this one. No, they did not. But if we were to calculate the area under this frequency polygon, we'd simply need to divide it into different sections. So how many different areas do you think we would have under this frequency polygon? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And the reason for that, we can look at the number of intervals here. So we have 1, 2, 3, 4, 5, 6, 7 intervals. And the number of area we're dealing with will always be 1 more than the number of intervals. And for the ungroup, it's going to be 1 more than the different frequencies we have. So if we have 10 different frequencies, it's going to be 11 area. So it's going to be 1 more than whatever interval we are working with. So 7 intervals is going to produce 8 areas. So they didn't ask us for the area for this one. So, well, when I send this document to you, you can find the area. And once you find the area, all you're required to do is divide by the class width, and then that should give you back the total frequency. So this one, the scale was 2 centimeter. And this is 1 centimeter to 1 unit. So remember, you need to have all of this on your graph. So this is just frequency polygon. What is this? Frequency polygon of time taken for students to finish a race. Alright, so everything is labeled, everything is on this. You'd get your full marks, be on your merry way. So this was what? 6 marks. And the final marks would come from this question here. So to qualify for the finals, a student must complete the race in less than 60 seconds. What is the probability that a student from this class will qualify for the finals? Where are we? Oh, here it is. So we're looking at less than 60 seconds. So we need to look at the number of students who finished the race before 60 seconds. So which interval would we stop? Repeat?
Second one.
The second one, because it says before 60 seconds. So we can say that probability qualifying for final student is equal to the number of students finishing before 60 seconds less than 60 divided by the total number of participants. So how many students finish before 60 seconds?
7.
7, because that's just the frequency here. And what's the total number of participants?
36.
Sure.
I don't know.
Add up all the frequencies. 32. And this would be the probability of a student qualifying for the finals.